Hello and welcome to this PV Tech Talk product series webinar co-hosted with FIMER. The title of today's webinar is an inverter's role in delivering high availability and low LCOE for a new era of utility scale solar. My name is Liam Stoker and I'll be your moderator for today's webinar. And joining me today are Maren Schmidt-De Angelis, Managing Director for Utility Line of Business at FIMER, and Marco Trova, Senior Global Product Manager for String Utility Solutions at FIMER. Before we start today, we have some housekeeping. Today's webinar will last approximately 1 hour. Shortly, we'll have Maren open proceedings, followed by presentations from Marco. Given that this webinar is to be dedicated to 2 separate solutions, we intend to open the floor to questions from the audience in between each presentation. So if you do have questions regarding any particular solution or product which is being demonstrated today, be sure to submit your questions via the dialog box which you can find on your screen. We'll endeavour to work our way through as many questions today as possible, but if we are unable to get around to your question, please provide your email address and we'll liaise with you directly. The slides and a recording of today's webinar will also be available shortly after the presentation. But without any further ado, I'll hand over to Maren to begin today's webinar.
Thank you very much, Liam. It's a pleasure to be here today, and let's immediately start. So, FIMER, a new era. Just briefly, our vision. We want to contribute to a cleaner and more sustainable world in a sustainable, innovative, and dynamic way through a complete portfolio of photovoltaic solutions for energy conversion and storage, and e-mobility solutions for electric vehicles. So, 2 mainstream businesses. Our responsibility here is to invest in highly technological solutions, to be reliable, and us and our solution, this is very important, and to build a world where energy is used in a sustainable manner for future generations. With passion, so people do make the difference. I know it's a technical webinar, but we really think that people are a big part. We evolve and improve, perfecting our know-how and our expertise. And this is reflected in the passion we put into our work, into the solutions we create, and into the technologies we design every day. With professionalism as well. So our mission is to be a customer-centric company. We are close to our customers in all challenges throughout the whole lifetime of their assets. Here I will come back later with expertise to ensure the quality and the distinctive excellence of our solutions. With flexibility, our market, as we all know, is a fast-changing market. We are quick to interpret changes and fast at adapting to market developments. We are able to constantly improve and we listen to the needs of our customers and work hard. Another topic which is raised more and more is ethical sourcing. So sustainability actually goes beyond carbon footprint and emissions. It begins with base raw materials. We are sourcing raw materials in accordance with international standards and practices, as well introducing some of our own standards to secure a supply chain free from corruption of people, planet. Now, FIMER, the new FIMER, our international footprint. So let's say, as I said before, we have 2 main businesses. One is solar, the other is electrical vehicle charging solutions. Solar is 90% of our business. We are operating in over 100 countries. We have direct presence in more than 20 countries. We have 3 production sites. We have 300 service personnel working worldwide. In total, more than 1,100 employees. And we have 3 R&D centers with 200 experts. Now, here's some key numbers. Maybe really to highlight this one, our installed base is over 55 gigawatts. We have a production capacity of more than 12 gigawatts per year, and we act in 5 continents. To come, talking about the inverter's role in delivering high availability and low LCOE, we get the transition now to an efficient utility portfolio with a new modular conversion concept. Marco will talk a lot more about this today, and this is also where you can see our two new solutions. So what we see actually, and this is, we started from there, what we see is thanks to innovative power electronics, the large string inverters are reaching the economical benefits of central inverters. What we see also is reduced project development time and costs require flexible solutions with multiple MPPT and wider voltage. And this, the last one, is a really big topic which we see, and this we listen to our customer and hear it continuously from our customers. Higher risk and cost associated to components or functional parts obsolescence is a long-term threat to them. So what we do, we want to address the string inverter market, which we see always increasing to 60%, but we also want to serve the central inverter market with a fully scalable solution for the remaining 40%. We want to focus utility developments and operations on a modular power building block, so reducing time to market and management costs. With unmatched flexibility and scalability. So we are not talking about one system size or two system sizes. We can adapt this to systems of any kind and any size. And the really relevant topic as well is we want drastically to reduce downtime costs for a system availability of 99.9%. So basically, we see a changing focus, and this also regarding our customers, from a pure Capex-driven market to a market which is much more interested in long-term availability and sustainability. And we think this must be reflected on one side on the structure, so on people being close to the customer, and on the other side in our product portfolio. We are agnostic, so as I said before, we want to serve centralized system layouts as well as decentralized system layouts, so to serve the whole utility market. And our approach is just changing by using string-based technology for decentralized systems, so a string, as we all know, with multi-MPPT, but also string-based technology for a centralized solution, which is like a typical centralized monolithic solution, but in this case, we use the modular string-based solutions for centralized layouts in order to improve especially the OPEX and the availability in the market. Now, I would like to, I'm done here, and I'm very curious about what Marco is going to say in the next minutes. Thank you very much.
Thank you, Mara, and my pleasure. This is Marco Trova, and I'm really happy and excited to introduce the audience to the new exciting technologies. As we learned from Maren, FIMER is going towards a transition to modularity, and modularity is going to be a mantra. So let me just try to give you a clue on what is going on at FIMER and how FIMER have the ambition to offer modular solutions to address 100% of utility scale applications, whatever is the customer preference towards decentralized or a centralized design concept. The first part of the presentation will be focusing on decentralized solutions and power electronics we have recently unveiled to address this market and to combine this technology with the latest innovations which are available from module makers. The first part will be focusing on this new PVS 350 solution for decentralized architecture. Let me give you as a sort of preamble, so that you understand what is going on also on power electronics, why we are seeing this kind of increase of power capacity on inverters at any level. So what we have seen on solar modules over the last 13 years is a progressive increase of the size of the quantum of energy, so the single cells growing from almost linearly over the first 10 years, with a steep increase over the last few years towards very large and giant cells of 210 millimeters, which are now the latest cells available on the market. And this trend was accompanying, of course, the progressive increase of power capacity of each single module. Over the last 13 years, we have seen modules starting from barely 300 watts in 2009, and now at the last Intersolar, we have seen single module capacity exceeding 700 watts. This was the combination of a significant increase of efficiency, of cell efficiency, of throughput of the manufacturing, as well as an increase of the size of the modules. But what is behind? Why module makers are going toward the direction of increasing the power capacity of the modules is pretty trivial task to respond to this, is to offer cost savings which are extending beyond the single cost per watt of the module. Of course, going bigger in capacity is a good way to reduce the number of installed modules per megawatt. And so in turn, this reduces the strings and cables, electrical balance of system, which are associated to interconnecting all of these modules, and reducing also the hardware cost, which plays a significant role in contributing to the capital cost of the system. So the side effect, the beneficial effect at the system level is cost reduction on logistics, a cost reduction on the mounting hardware, especially on tracker systems, which are significant part of the capital cost, and the electrical balance of cost decrease, which is, according to the latest publications provided by the tier 1 manufacturers, can promise to save as high as 0.9 euro cents per watt peak, which is a significant cost savings. Pretty much following the same direction, of course, you have seen on the market proliferation of inverters having increasing power capacity. If we look to the same time frame and look into our portfolio, we started to unveil the firstly worldwide available 3-phase string inverter back in 2008 with less than 30 with 10 kilowatt and less than 0.27 kilowatt per kilogram, and now the market is aligned on a maximum capacity around 250 kilowatt. So we have seen an increase of 25 times of the power capacity of the inverters, accompanied by, of course, a significant increase of the power to weight ratio. This won't be available without exploiting, of course, the latest innovations in power switching technology. Today, FIMER is presenting an inverter which is exceeding this limit, and is positioning FIMER to compete, of course, as a leading provider of power electronics with a single unit with a power capacity exceeding 300 kilowatt, 350 kilowatt actually. But is that the right way to go? Is going big really an answer to the mission towards cost reduce the system and reducing the LCOE cost? Yes, the answer, of course, is a question that we put to ourselves. And of course, any attempt of inverter makers to produce cost savings should not adversely affect the system yields, should not provide generate additional costs outside of the box of the inverter. So conversely, it should promote capital cost reductions, and as well, it should not adversely affect the logistics. So of course, there are challenges in going big in power capacity, technical challenges inside of the unit, but also we have to be careful not to adversely affect the system cost, but conversely to promote cost savings. And this is exactly what is behind the release of PVS 350. Why 350 kilowatt? 350 kilowatt is a combination, of course, of different conflicting requirements. No? First of all, going so big in power, it can compromise the system yields, especially because of the DC and AC conduction losses. But thanks to the combination of 350 kilowatt on 800 volts AC with 253 amp output and the ability of this inverter to receive very large aluminum cables, we are able to reach an optimal balance of the DC and AC cable losses, so preserving the maximum yields while contributing to reduce the capital cost. As far as capital cost is concerned, together with a slight decrease of the cost per watt of the inverter, we also can exploit additional cost saving at the balance of system to minimize the cost per watt of the system. In terms of logistics, thanks to the innovations we have introduced in this product, we are able to keep the form factor within the size and weight which are compatible for the Euro pallet, and so we are able to ship in a standard pallet to minimize also the logistic cost. That was from a system level perspective, but of course from a technology provider, how we have been able to reach such a record high capacity. There are three main factors which contribute together to enable this kind of super high increase of power capacity. First of all, as mentioned earlier, the availability of new power horses, the low losses, high current power IGBTs, which are the heart of the system. Thanks to the combination of these new technologies, new power IGBTs combined with multi-level topology, we are able, of course, to convert a larger amount of power and larger currents. But this is not enough. In order to increase the power capacity while keeping the form factor within the limits of a standard Euro pallet, there is something more that should be done to efficiently evacuate the amount of losses which are in any case generated inside of the unit. And this has been enabled by the adoption of the latest heatsink technologies which are offered, which promote the use of a higher power thanks to the 30% higher cooling efficiency. And of course, combining this increased cooling efficiency with an intelligent management of the other losses which are generated inside of the units, especially magnetic components, which have been pulled out of the inverter and moved into a favorable position in order not to adversely affect the other components inside of the IP66 enclosure. Last but not least, combining new components, better cooling efficiency together with an improvement in efficiency, especially in switching losses, and to reduce switching losses thanks to the new discontinuous pulse width modulation techniques, which are promoting additional efficiency improvement, and so reducing the amount of losses inside of the inverter. In a nutshell, let me summarize some of the key numbers, key figures of the product. The inverter PVS350 is able to deliver up to 350 kilowatt at 30 degrees, slightly derated to 333 at 40 degrees ambient. Very important is the 12 MPPTs, which we have introduced in this new generation with 45 amps, so that we are enabling the connection of the new ultra high power module. So this is a perfect fit for the new applications which will benefit from the cost savings of the ultra high power modules. This is accompanied with a very large and very wide MPPT range, and as mentioned earlier, 800 volts AC in order to minimize AC losses. Combined with these basic features, we complement the product with additional and desirable features which are inherently available thanks to the multi-MPPT technologies. Very important is the seamless communication and configuration capabilities of the inverter to reduce the time spent on commissioning and setting up the firmware, as well as the advanced diagnostic and prognostic capabilities that we have introduced through online heavy curve analysis to get rid also of fuses and to try to minimize the risk of course, of failures and preventing the propagation of failures thanks to the arc fault detection. Just to summarize the key highlights of these new technologies, this is the most powerful string inverter today available on the market in utility. We have the highest power to weight ratio in the category, exceeding 3 kilowatt per kilogram. The unit is compatible with all the latest ultra high power modules, and we complement these basic features with the string diagnosis and DC series arc fault circuit interrupter. As I mentioned earlier, let's make the side-by-side comparison of the new technology with the legacy products. The product with the highest capacity in our portfolio was PVS 175, which is 50% of the capacity. On a large 100 megawatt system, what does it mean converting the system to the new PVS 350? First of all, we preserve the yield as mentioned earlier, but we contribute to reduce the Capex. First, we dramatically reduce the number of components that shall be installed, as well as the number of MV stations. Thanks to the highest capacity we can collect on a single MV station with these new high power inverters. The benefits are 47% reduction on inverters, slight reduction on AC cables and trenches, which altogether contribute to 0.01 euro cents per watt at the system level. In terms of Capex, the main benefit is that through a larger capacity inverter, we can promote the adoption of larger MV stations. And this is very important because this plays a significant role in contributing to the capital cost of the system and to the installation cost. Comparing on a 100 megawatt project, the system designed with the 350 compared to 175, we can reduce the number of stations to 13 instead of 15. So we have 13% and plus of MV station reductions, and these contribute to 0.26 euro cent per watt of cost reduction at the system level for a 100 megawatt system. As far as logistics is concerned, the dramatic increase of power to weight ratio and power density is enabling us to combine up to 69 of these units in a 40 feet high cube container, compared to the 54 units of the PVS 175, which means that today we are able to ship 24 megavolt ampere per skid, per container, while with the former technology, we were just limited to 10 megavolt ampere. So 140% power per container increase, which convert into a cost saving of 0.02 euro cents. Just to summarize, we have discussed about the cost benefit of these new technologies in terms of logistic and installation, reducing 30% the overall cost thanks to the record high capacity. Saving makes it 0.03 euro cents combined altogether. I see in the electrical balance of system, we have up to 15% higher AC capacity for the station, which means less station to be installed. In a 100 megawatt system, this converts into 0.26 euro cents per watt. And very important is enabling the use of the latest ultra high power modules, which they bring the major part of the cost saving at the system level, according to the manufacturer, 0.5 to 0.9 euro cents. Altogether, this is exceeding 1 euro cents per watt of saving on a 100 megawatt plant, depending on the module technology, and thanks to this new inverter. Okay, before starting the second part, I think we would like to receive some of your questions. We will be happy to respond to your questions.
Excellent. Thank you very much, Marco. Yes, as Marco has just alluded to there, we do have some time for questions from the audience relating to the PVS 350 product. So if you do have any questions at all, please feel free to use the dialog box on your screen. We have a few already that I'm just going to get started with, Marco. Could you perhaps give a bit more detail around, or a bit of information around the standard warranty for the product and any extended warranty services that FIMER provides?
Okay, thank you, Liam, for the question. The standard warranty is 5 years, 5 years plus 6 months, considering the shelf life, which can be extended extended also all the way up to 25 years, based on service level agreements with the customer. With the customer specific needs, we are able to address also and to follow the system operating life to all the way up to the 25 years.
Excellent, thank you, Marco. Another few questions here. What's FIMER's proposal for power conversion, asset management relating to predictive versus preventative maintenance?
Okay, so the inverter is a key. These kind of technologies are the ideal playground to introduce prognostic and diagnostic capabilities. So the inverter is full, of course, of digital capabilities, which are able to, on one end, sense the healthy status of all the components inside of the unit. On the other end, the inverter is acting like a sensor for the system. So during the operating life of the system, we are able to actively monitor the healthy status of each string and to promptly detect and point our fingers on the faulty part of the system. So we offer the ability to the customer, of course, to efficiently serve not only the power electronics, the inverter, but also the upstream components, so the strings and the associated components. And this is possible thanks to the adoption of an advanced communication platform combined with all the sensors and digital capabilities which is integrated into our inverters. The communication of the inverter is for free to our cloud services, which is a sort of complementary solution which we are offered to our customers in order to, for free, to maintain and to monitor the status of their assets for the service life of the system.
Excellent, thank you, Marco. I guess maybe something of an extension on that previous question. Is there any offer around PV string diagnosis based on the IV curve analysis for the product?
Yes, the unit is integrating all the sensors and the digital algorithms which are required in order to periodically perform on demand an accurate scan of the IV curve of the solar of the strings. Through this IV curve scan, we are able to compare this real-time detected IV curves with a library of different curves which are stored in our system. And so we are able to classify on one end to identify if there is any deviation with respect to the expected IV curve. On the other end, to classify the failure mode. So depending on the shape of the IV curve, we are able to shortlist the possible failure modes which are affecting the single strings. The service, of course, is an additional service. Now we do not impose to the customers the adoption of the IV curve. IV curve capability is embedded in the hardware, but the customer can adhere to these additional services depending on their specific need. They don't need to adhere to this upfront. They can, for example, they can decide to test it, and then afterwards they can enable this on the system level, on a subset, or on all the inverters which are connected to the same system. So we are very, very flexible in defining an offer, a package which is in line with the customer expectation. So the capability, of course, is embedded, but enabling or disabling these features is according to specific customer requirements.
Excellent, excellent. Thank you very much, Marco. We've had a couple of questions here. I'm going to try to congregate them into one big question, I think. Is the offer also including the MV station? And could you perhaps give a bit more detail around what it includes? So does it include the MV skids, so transformer and switchgear, or do developers, installers need to find them from an alternative supplier?
Interestingly, this is one of the key differentiator of FIMER against the majority of the other competitors. FIMER have also the ability to design, manufacture, and deliver a complete package from our fully owned factories in Italy. So we manufacture the inverters here in 35 kilometers south of Florence, but we also design, engineer, and manufacture the medium voltage skid in Vimercate, which is a few kilometers away from Milan, in the suburbs of Milan. So we have the ability to control the full supply chain of all the components, and we have a made in Italy full solution, bundling together the inverters and the medium voltage skid. The medium voltage skid we are offering in combination with PVS 350 is a 20 feet solution, so with the ability to fit inside the 20 feet container. Is an outdoor skid, including the medium voltage switchgear, the oil immerser transformer, and the low voltage cabinet for dedicated line feeders for each of the units, with a capacity which is going all the way up to 7.7 megawatt. And we have plans also to expand this to 8.4 megawatts in the future. So yes, with the combination of the inverter and the medium voltage skid, I think is a desirable feature, and many customers are really interested in simplifying their supply chain with adopting these kind of solutions.
Excellent. I'm just lastly, I'm slightly conscious of time, so we'll wrap this up with this question on the PVS 350. What kind of communication and monitoring solution is on offer, or do you kind of prefer or propose?
Okay, the company have decided to invest only on a future-proof industrial standard communication infrastructure. So all of our product range, not only the utility range, but also the residential and commercial industrial range, is integrating Ethernet communication with daisy chain capabilities, supporting Modbus TCP communication. This is, of course, offering several benefits. Most relevant is that the customer is not binding to our monitoring and plant control solutions, but it can freely adopt any industry standard solution available on the market. This is especially important with the introduction of the new upcoming grid interconnection requirements, which are imposing rules not only to the inverters but also to the control system. So monitoring is for free for the lifetime of the inverter if the customer wants to enable the access to our Aurora Vision platform. But of course, thanks to the industry standard Modbus TCP communication, then the customer can in parallel implement any monitoring and control solution on the system without being binded to our portal.
Excellent. Thank you very much, Marco. We will be shortly moving on to a presentation surrounding FIMER's PVS 260 product. But if you do continue to have questions, please do feel free to continue posing them in the dialog box on your screen. We will have some time to address a few questions at the end of the presentation. So please do keep the questions incoming. But otherwise, I'll hand back over to Marco to continue the presentations today.
Thank you, Liam. So what we have seen on decentralized technology, the trend on power capacity, 30 times increase on inverters, the string inverters. Surprisingly, exactly the same record increase have been experienced by central inverters. If we go back to the 2008, a central inverter was a 100 kilowatt box. Today, a central inverter is a 3 megawatt plus building block. So 30 times, exactly 35 times, with exactly the same power increase we have shown earlier on string inverters. And this is again the learning curve of power electronics on solar. However, while this power was increasing for a very simple reason to help the industry to reduce the costs, all the downside, all the cons of going big in power capacity, which is peculiar to the central inverters, is still there. I mean, central inverters going bigger means that also you still have the very high sensitivity to single point of failures. The system is going to be very inflexible, and also you have a very long-term risk and exposure to system obsolescence and very high cost associated to operate and maintain the inverter. And this is pretty much the rationale behind the decision of FIMER to stretch the modular concept not only to the benefit of decentralized architecture, but also to the remaining almost 40% of the market, which is still dominated by centralized architecture based on monolithic inverters. So the product is on the show today. The second part of the presentation is to provide you some insight of what we are offering in order to be able to get rid of the monolithic central inverters, and so that you can adopt and use all the benefit of modularity, not only on decentralized solutions, but also on any system which will be better optimized using centralized architecture. Well, the key facts, the highlights are the powertrain we have developed for PVS 350 is efficiently used also to generate the key building block of this NVMCS. NVMCS stands for medium voltage modular compact kit. This is the most powerful single stage modular inverter available on the utility and is enabling us to seamlessly replace any conventional central inverter solution, keeping the same footprint. Now we are talking about the 40 feet footprint. Of course, thanks to the modularity, we bring to the market the inherent values of converting with smaller building blocks. First of all, modularity means reducing OEM costs compared to a central inverter, as well as minimizing the system downtime with availability which is exceeding 99.9%. And the modules, converting in modules means also offering full scalability to all power sizes needed. Extremely high flexibility. Okay, just to dive into the product details, the system is a perfect fit with any DC-AC ratios because we are able to offer single building blocks of PVS 260, which is a 262.5 kilowatt power module with 600 volts output, as well as 300 kilowatt module with 690 volts output. So we have the ability to replace all the conventional monolithic central inverters. Bundling together up to 24 of these modules, we are able to cover up to 6.3 megavolt ampere with the PVS 260 and as high as 7.2 megavolt ampere with the PVS 300. The single line diagram is showing how the system looks like internally. We have the very same medium voltage part with the medium voltage cubicle, the medium voltage, low voltage, medium voltage step up transformer, and the key factor is also the low voltage compartment where all the 24 power modules are individually protected in order to preserve the granularity, but also the selectivity in case of single point of failures. All of these components are fully integrated in our factories, so to offer a full true plug-and-play solution and fully controlling the supply chain. So these components are manufactured and integrated in our factories. What are the benefits compared to conventional central solutions? The most relevant is on the operating cost. Of course, again, we are considering the 100 megawatt project as the benchmark. If we compare the typical O&M activity cost of a conventional central inverter compared to a modular central solution, we dramatically reduce the cost per kilowatt of installed power from 1.5 to 0.826. And this is both on labor cost as well as the spare parts. Comparing the modular inverter with the central inverter in terms of spares, for a central inverter you have to spare a bunch of different components, fuses, fan, capacitors, modules. The reason is that all failures are converted into repair on site. So every single failure, you have to go on site, open up the box, and replace the single functional building blocks which have been suffering the failures. While for modular inverters, it is all about swapping a power module. So typically just 1% of the total units that are installed are available on site in order to quickly tackle any single point of failures. Inverter repair and replacement is also a relatively trivial task with modular inverters. You can use the customer technicians, unlike central inverters, which normally require a manufacturer to be involved, the expertise of a manufacturer, or a specialized trained technician. Calculating the impact of over the service life of the system, we are offering 1.3 euro cents per watt saving in 25 years. And this is the main improvement. As far as availability is concerned, today typically a 7 megawatt skid is composed of two central inverters. So while with our solution we have 24 independent horses running to generate the same amount of power. The difference is evident when a single fault happens. With the central inverter, you have 50% of the system offline, so you lose 50% of the capacity, while a module offline will generate just 4% of capacity loss. So low sensitivity to a single fault is one of the key attributes of this solution, and is enabling us to enhance the availability above 99.9%. Of course, the reducing also the mean time to repair, thanks to the lightweight of each power conversion module, less than 100 kilowatt. So it's easy to manage even from customer personnel. That won't be possible without complete segregation of each single building block. Each unit is individually protected, so that in case of a failure, the failure does not generate a sort of domino effect. Okay, so all units are individually protected to prevent that a single point of failure will adversely affect the rest of the system. Last but not least, it's also important that with this system you can effectively keep live the full system and just tackle the single point of failure, while with central inverter you have to completely keep the system off in order to repair or replace the parts, the failed parts. This in general is converted into an availability. Availability of central inverters maximum 99.5, while with our modular inverter we can exceed 99.9, and this is converted into a 0.4% improvement. As mentioned earlier, the system is composed by smaller building blocks, so we have the ability, combining different output voltage ranges and different power ranges, to match and to cross-reference all the existing legacy monolithic central inverters available on the market. So this is particularly important, not only for new power system, PV system, but also for the repowering business, which is growing, of course, relevance, especially since a lot of gigawatt installed capacity is approaching, the end of the warranty periods. So it will be important also to provide a solution for these systems. With the same footprint of a conventional monolithic central inverter, you see that we can provide one-to-one replacement for building blocks of 3 megawatt, 3.2 megawatt, as well as the largest capacities available today for monolithic inverters exceeding 7 megawatt. Okay, but all of these economical benefit, how they convert into LCOE? As mentioned earlier, the most relevant benefit of this solution is on the operating cost. So we have a monolithic central OPEX cost is 80% higher. Considering that OPEX is typically 10%, OPEX of the inverter is typically 10% of the overall operating cost of the plant, this is converted into an 8% saving on the operating cost. Together with the saving on operating cost, we have a net improvement of the yield of 0.4% thanks to the availability. which does not include any potential additional improvement thanks to the granularity of our inverter compared to a monolithic single MPPT monolithic central inverter. Combining these two benefits together, it is possible to reduce LCOE from 1.5 to 2.5% compared to conventional solutions. Okay, just a recap of what is available today with PVS 260 300 medium voltage modular compact skid. The main benefit compared to a conventional central solution. The key is the O&M. 1.3 euro cents watt saving, typical saving over 25 years, thanks to the granularity of the power conversion, which is accomplished with smaller and swappable power blocks. Availability is enhanced by 0.4% at least, comparing to 99.5%, which is maximum for central solutions, thanks to this inherent fault tolerance and reduced mean time to repair and labor cost, which is guaranteed by the modular conversion. Power density is the same of the conventional central inverter, so it's a sort of peace of mind for the customer, which can basically swap or convert his design from a monolithic central solution to this modular central solution without changing the design and the footprint of his system. And we are able to match one-to-one the power capacity of each single monolithic central inverter available on the market. And together, all of this benefit combines and contribute to generate a 1.5 to 2.5% saving on the LCOE on a typical 50 to 100 megawatt plant, which is designed with FIMER new modular solution compared to a conventional solution.
Excellent. Thank you very much, Marco. This is just another reminder to our audience. We do have some time for questions now, so if you do have any questions at all, please feel free to submit them on the dialog box on your screen. I'll kick things off. I'm going to breach the topic that I would imagine is forefront of many developers' minds, especially at the moment. With regards to cost, Marco, what's the kind of cost difference between the multi-MPPT decentralized solution, so that would be the PVS 350, and the modular central inverter solution like the PVS 260?
I think that the answer is that, as mentioned by Maren, these solutions, the decentralized and the centralized, will give complete freedom to the customer with an equivalent Capex, more or less the equivalent Capex, to select the decentralized or the centralized while keeping the same benefit, exactly the same benefit. There are systems that will more benefit for the use of centralized solution, typically those that have very high DCSC ratios, and also considering the trend towards the adoption of storage, while there are other systems where the combination of multi-MPPT inverters with mild to moderate DCSC ratios will give the most benefit and the lower LCOE. So the introduction of these two solutions will give the customer with comparable cost, capital cost expenditure. First of all, they immunize their investment for the future, because they will have from the single supplier a modular solution to get rid of their obsolescence and to benefit from the latest technology and any innovation that we'll introduce in the market, because we're going to replace this module with the new modules, which will give more power and will give also more efficiency, and with more or less the same capital expenditure.
Excellent. Thank you very much, Marco. Just a quick one, I guess. Could you just confirm when the PVS 260 will be available on the market?
Okay, so the two products have been unveiled and will be in ramping up in volumes 6 months ahead of the other. That means that the decentralized solution will come first, okay, during the second quarter of 2022, will be delivered in volumes in the Q2 of next year, while the modular central solution will ramp up in volumes during the second half of 2022.
That's great. And perhaps more a broad stroke question here. When would it be more convenient for a multi-MPPT decentralized solution to be deployed instead of the modular central solution and vice versa?
One example is where one solution will be better than the other in general is one criteria is the DCSC ratio, as mentioned earlier. There are systems which are designed with very high DCSC ratios. In those cases, the effect of DC losses is vanishing, because the inverter will run for most of the time with full power, saturated power. So all the excess power which is lost on the DC is not relevant, does not contribute to generate yield losses. In those cases, of course, a system which is connected as close as possible to the evacuation point, which is in the medium voltage, is preferable, because in this case you minimize the AC losses thanks to the centralized solution. Conversely, a decentralized solution is suffering slightly higher AC losses because the inverters are distributed in the field. So depending on site by site and depending on the location, you may have a break-even point anywhere between 1.08 to 135% of DCSC ratio, where one solution may offer better yield and better economical benefit than the other solution. This is one possible selection criteria. Then there are many other criteria, of course, but this is the one that probably is more easy to monetize. I mean, to be used as a selection criteria.
And I guess by extension, then, are there any particular countries or markets or regions where the central conversion concept is better suited?
These are we are we are drifting from technology to cultures. No, there are different PV cultures. Then in general, for example, if we look to the European market, the Spain is more in favor of centralized architectures for a number of reasons, historical reasons primarily, as well as South America, and also North America for sure. So in those countries we see, and not to name Australia, in those countries we see this new MVMCS as one of the the most attractive markets where this technology may provide significant improvement. Conversely, other markets are already more educated to use decentralized solutions, or for example, Northern Europe and other countries, also Far East and Middle East countries. Also, they use some of these countries. They use decentralized. So I think with this modular central solution, we will be able to crack the resistance of countries which historically have been addicted to monolithic central inverters, because of course they will realize that with this technology we can bring more values while keeping the design unaffected.
Excellent. And I think just one last one from me, really. Is there any kind of information you can share regarding the compatibility with AC/DC and indeed kind of energy storage as solar begins that kind of transition itself?
Yes, the modular central solution will be natively bidirectional. So with this solution, of course, the roadmap includes the compatibility also with modular storage systems. So we have a plan to evolve towards the integration of this modular solution into an hybrid scheme where we can combine a PV with the storage on the DC side. And we see this a trend in the industry to adopt modularity not only in the PV but also in the PV combined to storage. So I think that our modular conversion platform is ideally suited to contribute to the transition to a larger adoption of PV plus storage in the future.
Excellent. Michael, we've just had one final question. I'd appreciate we've got a few more minutes left from the audience. Perhaps you could give a bit more detail around FIMER's position on kind of high voltage systems. So that would be kind of 1500 to 3000 volts if you're able to.
This is something we prefer not to disclose at this stage. Of course, we are looking with interest into this kind of transitions, but we prefer not to go into details, not to disclose our plans.
Sure, absolutely. Unfortunately, that is kind of all the time we have for today. Appreciate that there are a few questions that we haven't got around to asking. So what we kind of intend to do is to leave the dialog box open so you can continue to submit questions, and we'll endeavour to answer them privately. Of course, the presentation and the recording will be available shortly, so keep your eyes peeled on PV Tech and the digit inboxes for that. A huge thank you to FIMER and indeed Maren and Marco for taking the time to share their insights today. And thank you indeed for all of our attendees for their attention. Thanks again, and we hope to see you next time.